Hello everyone, welcome back. I think in these videos I'm going to try something a little different. I'll try to have a running table of contents on what I'm going to talk about, both for my reference as also well as for you, so you can kind of use your tracking on the video to get to the points that you want to get to, and perhaps use that as a reference sake as well as learning. So hopefully this will help. Anyways, going still into the equations and entering in equations and formula into Excel. There are two ways you can enter in a number in Excel, and that is through what we call absolute referencing and relative referencing. And so you've already experienced relative referencing with the table that we've created. And let's say, for example, we'll have a table of, I don't know, patients. Let's call them patients 1, 2, 3, 4, 5. All right. And let's say this patients have a number of days they stayed in the hospital, and let's have total cost of stay for each patient, because apparently I am now going to become a accountant for a hospital. So let's say the patient 1 stayed 4 days, 3 days, 2 days, 5 days, 1 day, and the total cost of stay is going to be the number of days times whatever the cost of stay is. And so the relative referencing, cost of stay per day, for relative referencing we can, let's move this over. I will bring this back, just showing the quick editing that we can do. So if we say the cost of stay per day for these patients, let's say is $50, and we can say this is $75, this is $25, really cheap hospital, by the way, $10, maybe these are copays, I don't know. Anyways, the cost of stay, we would just simply again do the multiplication. The fact that we can just have these cells reference and move down with them, so really the calculation that's being done is relative to the position that the two cells are that are being multiplied to the actual cell. That relative reference is what we're dealing with. That's what allows us to do these combinatorial calculations within the cell. Now, of course, if they all had the same price, we could simply change them all this way, right? We can change them all the same number and do that relative referencing. But alternatively, we could actually reference an absolute position within a cell, so that cell doesn't move into calculations, but all their cells were. So let's say I created, let's say for example, I got rid of this table, this column, delete it. You'll notice we get a reference here now because the reference to the cell that we had is no longer there. So we get this little error that says reference missing, and so we know now that we have to fix that somehow. So let's go ahead and create a cost per day field. Let's say it's $50. Okay, I have to give it a dollar symbol. Okay, so now if we want to do a relative reference within a table, all we need to do is use the $sign as an indicator that that position will not change. So for example, if I wanted to have this cell always be referenced no matter where it is on the in that formula, if I copy and paste that formula, it always references I3 always. All I need to do is put a $sign in front of the I and the 3. Whatever column, if the column has a $sign, then the column is locked. If the number has a $sign, then the number is locked. If both, then it's a physically locked position. It's an absolute reference. You'll notice those numbers just popped up mainly because I hit the F4 key. The F4 key is a quick reference to change a number from a relative position to an absolute single position to one that has a locked column, a locked row, I mean, and a locked column. Or you could just manually type in those numbers. But in this case, I can say times the number of days, Control D, and you'll notice now that this is locked in, and we can use that relative reference throughout the position. Very simple way of getting at this. Alternatively, you can use this feature as a way of doing a combinatorial math for lots of data. Let's say we wanted to know the length and width or the area of a variety of different lengths and width rectangles. So we can put length in the along a column of lengths in this direction, and we can add widths and along this way. So let's say I said length in feet. We can say 1, 2, 4, 8, and 10. You'll notice the number reference is still existing there. I'm going to get rid of that by saying right-clicking the drag option and say fill formatting only. You see, I got rid of that. And then over here, I can do the same thing with, let's call this our width, and then in feet. And in this direction, I can do 1, 4, 6, 8. And one of the things you can do here, you notice this formatting is a little goofy and it doesn't quite make sense to us. I'll clean that up in a bit. One thing you can do is you can have this reference, this length, merge across the entire field, so you know you're talking about all of these as being lengths. So I can merge cells and center, and you'll get a nice little title that references this as the feet. And so I can, let's highlight this as a way of linking them so that you know what we're talking about. I can do the same thing here, merge and center. I like to have it centered in the vertical direction as well, so I just click the vertical alignment up there, and I can highlight these. Let's give this a different color. I feel like Bob Ross right now. Okay, there we go. So we have these two colors. So now we can create an area table where we'll get a combination of areas for every permutation of length and width. So we can do this by the relative referencing fairly simply by simply saying we'll hold this, and in this case we don't want this number to move down in the multiplication. So we want the row to be locked, but not the column. Conversely, for this one, we don't want it to move along columns, but we do want it to move along rows. So we'll lock the column, but not the rows. And so now we can go all the way across, and we got a nice little table of areas for our system. And I'll shrink this down to something really useless, but you get the sense of how we can take advantage of this approach and use this as a way to get a lot of data, a lot of calculations very easily, very fast. And that's just using relative reference or absolute references. It's a very powerful tool, and one that you will definitely need to learn and become comfortable with using. And so that kind of dealt with that, so I'm going to highlight that one. And now we're going to go on to our named references. So named references is another approach on how we can actually reference fields, cells within a column. So I'm going to go ahead and just delete this. Notice if I say delete, if I hit, let me just show you a couple quick other tricks. If I hit the delete key, you'll notice it deletes all the numbers, but the formatting and everything is still there. Oftentimes we don't want that. We want that to go away. So we can go over here and say delete, and it'll ask us how we want to shift the cells, because it's going to physically just delete those cells, and we can either have them shift left, shift up, doesn't really matter which way in this case, but for our cases we'll just say shift left, and that's fine. If you want to know what that means or how that looks, if I put fields over here, and I'm just going to go all the way down just to give you a sense of what this is actually happening. If I select all these and I say delete and I say shift left, you'll notice that this column here all moved over because those cells were physically removed from the field, and this just shifted over. You'll notice these didn't move with it because it's outside the selection range that we had. So it's a useful thing to understand, to just know how Excel handles these edits. I'm going to change these column alignments so you can see what's going on there. All right. So the next thing I wanted to give you a sense of is say a named referencing is another approach we can do within cells, within Excel. It's a very useful feature, but it also is very dangerous in a sense that knowing how to use it is great, but it can cause problems in some cases. So I would say proceed with caution, but it is an important understanding of how this works. Let's say we're going to do an equation that we're going to calculate the volume of a sphere, right? And so let's say volume of sphere. Well, volume of sphere, we can have a cell that we call radius, and the radius will give it some value. Now, of course, we can just use the relative reference of, what is this, G3 as our reference point. You'll notice over here it says the cell that's active what its what position is. It says G3. However, you'll notice in this cell I can actually edit that and change it, and I can change it to radius. Now, what's interesting about that is if I ever want to go to that cell, radius, I can just go back to radius here, type it in, and it instantly goes back to that cell. So it's a great way to navigate if you wanted to navigate different positions. If you don't remember the name, you can always click the drop-down box, and it'll list the named cells that you have there, and it'll go to that. Named cells don't need to just be a single cell. It can actually be an entire selection, and we can call this selection, oops. We can call this, there you go. We can call this big box, I don't know. And so if I ever want to go to big box, it'll instantly go to that selection as a whole entity. Again, it's sometimes useful, sometimes not, depending on what you're trying to do. So, but the key advantage to this is now when you do an equation, you don't longer have to use G3 as a position. You can actually type in radius and it'll know what you're talking about. So I could say 4/3 times 3.14 159 through pi r cubed times radius, and you'll notice down below it even Excel has a habit of anticipating what it is you're going to be doing. I could just type that in and use that as our cell and exponent 3, and we get our value. And so that's the power of that approach. Now note, one of the tricks to absolute references is it's always going to be an absolute reference. It will not move with the cells. And so you're not going to be able to use relative referencing. If you want to use relative referencing, don't use these absolute names. However, the other trick is sometimes if you use a name that is also the same as another formula, for example, that can cause major problems as well. So just be careful of that. So once you have a relative reference or a named reference defined, you can actually go in, if you want to remove it from the field, you can do that. You'll have to go to Formulas, and then under Formulas, you go to Name Manager, and you'll see here that you have all the names that you just created. It gives you the values and so forth, and you can just delete them. So click OK, delete, OK, close, and you have that fine. And you'll notice once we deleted that reference, we now have a name problem because there's a value here in Excel that it just doesn't know what it is. It has a name that it doesn't know what it is, and so you can go back and change this to what you want it to be, and that's it. So those are, in a nutshell, named references for Excel. So let me highlight that, and we can now go on to order of operations. This doesn't need to take too long, but this is probably one of the most common errors that are made in Excel. If I was to bet, one of the most common reasons why students make mistakes or miss points on an exam is because they've messed up the order of operations on an Excel. And it's important because obviously you want to make sure that your equation is entered correctly. So order of operations is the standard one for math, that your parentheses are going to be calculated first. our first, and then you're going to have obviously the second is your exponentials. Third is going to be division and multiplication. Fourth will then be addition, subtraction. So make sure that whenever you enter in a field or a file that you know what it is you're entering in, and that the order is correct. Parentheses will be your friend, but they can also be your enemy in terms of making sure if you put too many in. So just keep that in mind. So let's consider an equation. For example, we can take let's say 5 plus 3 to the third power. So obviously if I say 5 plus 3 to the third power, this is going to say 5 plus 3 to the third power. So 3 will be taken to the third power first, then added to 5. If I meant to do 5 plus 3 to the third power, then you'd have to make sure that the parentheses are there, because then those will happen first, and then the exponential will happen next. This is just a standard order operating procedures. One thing to note, and the nice thing about Excel, is it does color code the parentheses to help you keep track of what's happening. So if you have a more complex equation where you're going to have multiple parentheses, you'll notice each one gets a different color. And so if I said 5 plus 3, that's going to now match that parentheses, and it's going to show you where it's matching parentheses. So I can say divided by 5 minus 3. It's going to match that again to the second squared power plus 10 minus 100. And I don't know if that's the right number or not. I don't know what this equation was. I just wanted to show that the order of operations is followed. It's very precise, it's very easy to see, but make sure you understand the coding that's happening there so you can avoid making mistakes, because honestly this is probably the most common error, is not paying attention to the parentheses and where they are at. But Excel does kind of walk you through that. My advice to you is, if you ever wanted to double check your equation, do it by hand. Start with numbers that are very simple so you can do the calculation quickly and make sure that it's entered in and that gives you the right answer. Once you know that's right, then you can use the actual references that you want and go from there. But it's important to get your order of operations down. So with that said, we can now go into formulas for Excel, and I'm not going to go into, and I just realized formulas. We're not going to go into all of the options here. I'll have another file after this to go through some other examples of formulas that are important. But this is the most formulas, I should say, but functions are the most useful feature of Excel that you have. Functions are built in into Excel and do a lot of calculations for us without us having to code anything in. And these functions are really the power and strength of what it is that Excel can do for us. So what do I mean by functions? A function is just any call that gives a specific value or answer. Arithmetic functions, as you may know, are like things like sine, cosine, tangent. You can have an average function. There are dozens, if not hundreds, in Excel that are already built in, and I can't possibly go through all of them to show you what they are, but it's easy for you to learn them on the own and see what they are. And so one thing you can do to pick up functions and see what's built into Excel is to go over to this insert function site over here, and you can see that you have this large list of functions here that are built into Excel. You'll notice it's giving a category of most recently used, but you can select all and you'll see that you have an enormous set of functions that are built into it. And the nice thing is it actually gives you a pretty useful description on what it is that it means and how it's used. but I can go to things that are common. Let's say, for example, average, most common function that you can have, and click OK. And the nice thing is this function tool, Excel has this function tool that if I go through this route where I click this button, opened up function and went through here, I can actually enter in values in this point and kind of have it help me through entering the function correctly. And this is a great way to learn how functions exist and are used in Excel. You'll notice I can enter in numbers independently as individual fields, and you'll notice it's adding each function here as a separate number. It gives a number, comma, number, comma, number, comma, and this function is going to average all those together. Alternatively, I'm going to delete this, and so let's just actually say there, hit OK, and it gives you the average, right? Alternatively, I'm going to keep the same numbers, 10, 12, so 10, 12, 232, and 1, 2, 3. Alternatively, I can actually just enter in this function as a selection range, as a range selection. Range. And the nice thing about Excel is it's not going to let you make a typo in the sense that if it's typing it incorrectly, you should see that function underneath the underneath what you're entering in. If you don't see it, you might have a typo, so make sure you're following this right. And it even gives you a hint as to how to enter in the numbers, what the expected format is going to be. But I can select here, select this entire range as a range. So I'm just selecting one, holding down the cursor, mouse button, and selecting all that, and get the same answer that way. So that is how functions are addressed within Excel. There are a lot of them to use. Some of them are very simple, so you can actually break it down by the standard forms. Let's go to things like the math functions, for example, because I think it's important to see how things like cosine, tangent are used. So for example here, cosine. Cosine function will give you an answer. So one of the important points to note in Excel is the number is the angle in radians for which you want the cosine. It doesn't do this, it doesn't give you a function in degrees. So obviously cosine 90 is wrong. What it wants is in degrees, and so in radians. So I can say pi divided by 2, and it gives you 0, right? Or as close to 0 as it can possibly get. Note this isn't 0 because it's an imperfect value, but it's as close as Excel can give you to this. If you ever see in Excel give you a number that's extremely small, like e to the negative 17 is times 10 to the negative 17th number, likelihood is that it really means 0. But I can just say pi, and it gives us negative 1, right? And so realize that cosine is in and sine and all of these functions are going to be in radians. Well, that's not that big of a problem for us because we could actually still have Excel calculate radians for us by using radians function. So if the radians 90, it gives us the value, and then I can say cosine of this, and it gives us that almost 0 value for the result. So realize that Excel does allow you to do these kinds of calculations and these kinds of manipulations within the field. So that's an important part of the Excel feature set. One other point to note, and I'll just get on this, is realize that a lot of what you're going to be using in Excel in any kind of software is oftentimes running into something that you don't know how to do, and you'll be surprised at how helpful actually the help files can be in Excel. I gave you a quick example with with using the insert function here, but you'll notice down here there's a help on this function option. I can click on pi. I used pi as a value, and you noticed pi to enter in pi, I had to say parentheses to give us a value for pi rather than entering in a number. If I wanted to know more about that value, I can go to help on this function. And it'll come up and it'll actually break down and explain some more things to us. First and foremost, it tells us it returns the number of pi to 15 digits. So it's not an infinite version of pi. I mean, it obviously can't be, but it's only 15 digits. And this explains why cosine's function value doesn't give you a zero value. It gives you a near zero value. And this is the key reason for it. There's a limitation to it, to this function. And it gives other data as well as how this comes about. But besides this, there are other examples of functions in here that can be quite useful. So for example, let's go to something more useful. Well, let's find it out. Let's search for a function. Let's look for conversion. As we are engineers, let's go convert. As we are engineers, we often like to find converting units and being in the right unit set. So we can click convert and click OK, and we can ask for help on this function. And the nice thing here is convert, as you can see, will convert a number from one measurement system to another. And here what it's looking for is a number and then a unit entering and to another unit. And so if you want to know what units are available to us, we can just go to the help file and it gives us the units it knows and that it can use. And it shows you how you have to enter in the value to get that. So year is in quotation marks year, quotation mark day, or D, and so forth. So you can scroll through here and see all the unit conversions that you want or that you need and go from units to units. This is just a very simple way of knowing how to convert it. If you need help, if you want to get ideas for this, you can see over here it gives examples of formula and how it's going to work. Here it gives an example of converting pound to kilogram by just entering in those things. Further, it gives an example of converting degrees Fahrenheit to Celsius. Convert from data types. It'll tell you if you're trying to convert from mismatched systems, how that's going to look, and so forth. So, and it even gives you advice as to how to convert square feet to square miles. And here it just shows you converting twice, right? So you can get a sense of ideas of how this can be applied in help. That's actually quite useful. To end this off, let's look at the example it gave on Fahrenheit to Celsius. So let's say it's kind of cold outside, so I think it's like what, 32 degrees Fahrenheit, or it's probably colder than that. Let's say it's 22. And I'll label this units. I could say F or degree F. Really quick, another quick tip: if you ever want to enter in a symbol for a degree symbol, you can go to Insert, go to Symbol, and enter in the symbol here. I find that kind of painful way of doing it and not the most useful. However, if you notice in these, if you notice, sometimes there are these symbol codes that you can use. If you hold down the Alt key and then on your number pad, it has to be your number pad, you type in 0186, you'll get the degree symbol entered in. You hold down Alt, type in 0186, let go of Alt, and then a degree symbol will come up. Similarly, Alt 0181, the micro symbol will come up and be useful. So, degrees Fahrenheit. So now let's say I want this to be converted into degree, to degree Celsius. So I can say convert number from, and we'll go to F, or let's scroll down. We can scroll down, look for Fahrenheit. Where's Fahrenheit? F, that's right, okay. And we can go to degrees C, and that's it. And that's just how we could do the conversion, fairly straightforward. So that is, I think, some basics of Excel help. You can get to help by hitting F1 again and just doing a search for different things will give you some very useful hints. Excel's help files are actually surprisingly useful and surprisingly good, so I definitely encourage you to look at that if you have time. I think that ends this section of the presentation. Take care.